Next section that we'll look at is titled Pascal's triangle. Pascal's triangle is a definition or table that we'll use to solve problems in the next section. To start off Pascal's triangle, we'll start with the single number 1, and underneath of that we'll put 2 more 1s. This 1 is considered the first row, these 2 1s are considered the second row, and we'll continue down and we'll do 9 total rows for Pascal's triangle. To get the third row, what we'll do is take the 2 numbers above, 1 and 1, add those together, which will get us 2 for the third row. The outside numbers will be 1s. So our first row would be 1, our second row would be 1 and 1, our third row would be 1, 2 and 1. For the next row again, we take 2 numbers above, 1 and 2, add that, and it goes in between the 2 numbers for the next row. We also have 2 and 1 over here. We can add those to make a 3. And to make the triangle shape, always put a single 1 on each side. And again, now we have 4 rows. We will continue down until we have 9 rows. 1 plus 3 would be 4. 3 plus 3 would be 6. 3 plus 1 would be 4. And the single 1s on the outside to continue the triangle shape. 1 plus 4 would be 5. 4 plus 6 would be 10. 6 plus 4 would be 10. 5 and the 2 1s. The next row would be 6, 15, 20, 15, 6, and 1 on both sides. Next row would be 7, 21, 35, 35, 21, 7, and 2 1s. This last row that we did, that would be row 1, 2, 3, 4, 5, 6, 7, 8, and we'll continue on to do 1 more. That would be 8, 28, 56, 70, 56, 28, and 8, with 2 1s on each side. This will be Pascal's triangle for 9 rows. You could continue on the triangle. I'll put dot 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 because you can do as many rows as you need to solve different problems. Couple patterns on Pascal's triangle. Each row increases by 1 number. The first row has 1 number, second row 2 numbers, third row 3 numbers, fourth row 4 numbers. So the 9th row would have 9 numbers. Also, the triangle is perfectly symmetrical. Whichever number you have on one side, you have the same number on the other side. Section we'll use Pascal's triangle for is titled Using Pascal's Triangle. The definition for this one is we will use row exponent plus 1. So in these questions, whatever the exponent is, we'll add 1 to that, and that's the row that we'll use for Pascal's triangle. First question, and only question for this section, is expand x plus y to the 7th power. To actually solve this algebraically, x plus y, you'd have to write 7 parentheses with x plus y, go through and FOIL each one out until you come up with the polynomial for the answer. The shortcut method is we can use Pascal's triangle, and we'll use row exponent plus 1, the exponent 7, so we'll be using row 8. Looking back at Pascal's triangle, row 8, if we write just the numbers down with commas, it would be 1, 7, 21, 35, 35, 21, 7, and 1. To get the answer for the expansion of x plus y to the 7th power, we'll take the first number, which is 1, followed by the first variable, which is x. The exponent will be the exponent originally in the question, which is x to the 7th, followed by y. The second variable will always start with a 0 exponent. And this will be our first term in the sequence, 1, x to the 7th, y to the 0. And then plus our second term will be the second coefficient or second number, which is 7. The exponent on the x will decrease by 1, x to the 6, while the exponent on the y will increase by 1, y to the 1st. Plus the third term, we'll use the third number, 21. And again, we'll take x, decrease by 1, which would be 5, and the y exponent increases by 1, which will be 2. We will continue this pattern for all the numbers in row 8. After 21, we'll have 35. X will decrease by 1, x to the 4th. Y increases by 1, y to the 3rd. The next number, 35 again. X will decrease by 1, and y will increase by 1. Plus 21, x squared, y to the 5th, plus 7, x to the 1st, y to the 6th, and our last term, plus 1, x to the 0, y to the 7th. All these terms will be our final answer for the expansion of x plus y to the 7th power. A couple patterns about this. Again, the numbers are symmetrical. We'll have 7s and 7s, 21s and 21s from the Pascal's triangle. Also, if you look at every exponent, every term, they all add up to 7. And you should begin with the exponent 0, and you should also end with an exponent 0. The 0 exponents we can cross off and ignore, because y to the 0 and x to the 0 is equal to 1. And also, if you wanted to, you could take off the 1 coefficients and just have x to the 7th and y to the 7th.